Thank you very much, everyone. Welcome to this video. In this video, we'll be talking about implicit function. Implicit function is another parameter, another topic in further mathematics, that must be learned. Now, when we say implicit, implicit connotes latent, parts, or partly. So to differentiate implicitly means to differentiate partly. You differentiate partially. Are you okay? Now, in this video, I would like to remind you of the formula or the process of deriving, y with respect to x, or deriving functions. Let's say we are trying to derive y with respect to x by this existence, y equals to ax raised to power n. Obviously speaking, we have our dy dx or y prime as a multiplied by this power n. So we have n, then x raised to the power of n minus 1. This is the general formula. And what we are saying here, let's take, for instance, we have y as 4x raised to power 3. Obviously speaking, dy dx is going to be reading 3 multiplied by 4, which is 12. And then drop this power 3 by 1, and then you have 2. And so the answer has come 12x raised to power 2. And so this idea is going to be judiciously used here. Now we have 3y squared x raised to power 4 minus 5xy squared plus 2x plus 5y equals to 6, people of God. Now, we are going to be differentiating implicitly, and what's assurance, or what has inspired us to have known that this expression needs to be differentiated implicitly. Now, if you study this very relation, you can see that there is a powerful coexistence of y and x living together as an entity, So in this case, you must derive partly. That is, as you are deriving one, you are leaving the other. Deriving one, leaving the other. So let's say, for instance, you are starting with y. But please, I would like you to take this vital information. Each time you're differentiating x, you leave the answer the way the answer must have come. The expression has come. But if you are doing for y, please, your answer must attract dy dx. What are we saying here? Like 3y squared x 4, if you are deriving y, the power of y is 2. So 2 times 3, we have 6. And then the power of y, which is 2 minus 1, we have y raised to power 1. But you don't need to put 1. Then don't forget the variable x to the power of 4. Plus, now it's now time for, okay, now we just derived y. Please don't forget the instructions. You now put dy dx, excuse me. Now, let's now do for x. If you are deriving x, the power of x here is 4. So we are using this same 4 to times this coefficient 3. So 4 times 3, we have 12. This y squared minus 12, y squared x cubed minus 2. People of God. At this point, we need to make our dy dx the subject of formula by dividing through by the constraints. The constraint here is 6y. The constraint to dy dx is 6y x raised to power 4 minus 10xy plus 5. Then also here we'll be taking the same constraints to dy dx. So, of course, this will get cancelled out, and then we have dy dx rounding up to 5y squared minus 12y squared x raised to power 3 minus 2 all over 6 yx4 minus 10xy plus 5. And then from here, we have our answer. And then don't forget, this is the answer. Don't forget that the question has conditioned us to derive our gradient at 2, 1. Please always know and note that finding gradient in differential calculus is finding dy dx. So to find gradient is to find dy dx. So the corresponding value here, we are saying that at this point, x must be seen as 2 and y 1. So transfer the values straight into this expression. And then we have 5 brackets The value of y over there is 1 squared minus 12 brackets 1 squared 2 cubed minus 2 all over 6 brackets the value of y, which is 1, the value of x raised to power 4, we have 2 raised to power 4 minus 10 into 2 into 1 plus 5. Then we have 1 squared to mean 1, 1 times 5, 5, 1 squared, 1, 2 cubed, we have 8 times 12, you have 96, minus 2, all over 2 raised to power 4, 16, 16 times 16, you have 96, minus 10 times 2, 20, 20 times 1, you have 20, plus 5. And then from here, you have your answer. 5 minus 96 minus 91 minus 91 minus 2, you have minus 93, minus 93 over what? 96 minus 20, 96 minus 20, you have 76, 76 plus 5, you have 81. And so the answer is minus 93 over 81. Then in your normal fraction, mixed fraction, you have minus 1 over number 12 over 81. Be blessed of the Lord. So please, if you find this video so interesting, and I believe you will find it so interesting, so please quickly right click on our channel, YouTube channel, and then we get blessed together.